I guess I would like to come at this from a slightly different perspective, if I can add something to the conversation. The point has been made over and over, I think, by Mark and others, that humankind is confronted by a number of challenges that are global or planetary in scope. And so that there is a need for transdisciplinary knowledge oriented towards problem solving, and particularly the problems that are so urgent at a global scale. It seems to me that what underlies the need for a new paradigm in education, the challenge is to communicate understanding of complex systems. Hazel referred to the Earth system, and in the age of the Anthropocene, our interventions, our collective interventions in the Earth system have evolutionary force. The future of humankind is in large part now determined upon what we know, and based upon what we know will contribute to or determine how we act. Humankind has been very good at science, taking things apart in the search for timeless and universal laws. This reflects very much a Newtonian view of the world, whereby we are observers of a complex system whose future is determined by the universal and timeless laws which govern its evolution. What we are not so good at is synthesis, putting these bits and pieces back together and putting them into the context of here and now, or in the context of time and space, which is what we will have to do in order to confront the challenges we are facing. It seems to me that coherent societal action with respect to these challenges requires the communication of understanding of complex systems. That's sort of the basis or the challenge to education. As far as I'm concerned, one of the most effective means, or perhaps the only means, of communicating an understanding of complex systems is simulation techniques. By and large, if a system's response is complex and different at different times and in different parts of the system, there's far too much for the human mind to grasp and understand. And the only thing that we can do is use the power of computers and computation to augment our capacity to foresee the consequences of the actions that we might take, and we collectively. I would just close this thought with a quotation from Alan Kay. Many of you will remember that Alan Kay was one of the gurus at Apple Computer Company, primarily concerned with the use of computing for education. And here is his thought on the subject of simulation in education. He says, excuse me, he says the heart of computing is building a dynamic model of an idea through simulation. Computers can go beyond static representations that can at best argue. They can deliver sprightly simulations that portray and test conflicting theories. The ability to see, and I like that notion in particular, that you use the computer to see or to extend our powers to perceive, with these stronger representations of the world, will be as important an advance as was the transition to language, mathematics, and science from images and common sense. It seems to me that Alan Kay's insight has not really been realized in the use of computing capacity for education. And my thought is that built into the curriculum that's required for the future will be a much stronger use of simulation that will provide us with the power to synthesize and to foresee the consequences of the actions in such a way that coherent action can be taken. I guess that's what I'd like to say. Thank you.